So after yesterday, how comfortable are you with greatest common factor? Much more comfortable? After yesterday, how more comfortable are you with difference of squares and sum of difference of cubes? Because you have to be able to do all of that to factor by grouping, right? How confident are you factoring by grouping? Amazing? Excellent. Okay, great. That bodes very, very well for today. Okay, so here goes the title. Oops. IA, trinomials, A equals 1. So first thing I want you to know, I'm going to come over on this side. I want you to know ax squared plus bx plus c. That's a general form of it's called a quadratic. We haven't talked about it yet this year, but just so you know, that's a general form. Okay? But where is the a? In front of the what? X squared. Where's the b? In front of the x, and where's the c? By itself, no variable with it, right? So if I ask you to do this problem, x squared plus 5x plus 6, could you identify a, b, and c for this problem? Would you do it for me, please? So that's a, right? And that's b, and that's c. Now, I'm going to be a little picky and make sure that when you underlined A, you didn't underline the x squared. And when you underlined B, you didn't underline the x, right? It's not the x, it's not the variable, it's the number sitting in front of the variable, the coefficient, right? Okay? Because when we're factoring trinomials, I'm going to need you to know AC. What am I asking you to do with A and C? Multiply them. Okay, so in this problem, what's A? And what's C? 6. So what's AC? 6. And what about B? What's B for this problem? 5. So what I'm going to need you to do is I'm going to need you to think of two numbers that multiply together to be AC and add to be B. Okay? So first thing I want you to do is think about numbers that multiply to be 6. They are 1 and 6 and 2 and 3. Are there any other numbers that you can think of that multiply to be 6? So which combination of these two add to be 5? 2 and 3. You okay with that? So what we're going to do is we're going to take this middle term and we're going to split it into two parts. X squared plus 2x, because that's what you just told me, plus 3x, because that's what you just told me, plus 6. So I took the original problem, rewrote it, and I split the middle term into the two parts. Isn't this still an equivalent expression? Because isn't 2x plus 3x equal to 5x? Okay, but I chose these two specifically because these two numbers multiply to be AC and add to be B. Well, now how many terms does it have? I wish I would have taught you how to factor by grouping yesterday. Oh. You already know what to do, don't you? Greatest common factor, greatest common factor. What is the greatest common factor between x squared and 2x? X. What's left? X plus 2. What's the greatest common factor between 3x and 6? 3. What's left? X plus 6. Oh, I mean 2. What's common? X plus 2. What's left? X plus 3. Done. How easy do you think that is? But what if it was easier? What did you tell me that the two numbers were that multiply to be AC and add to be B? This is a trick that works when A is 1. When A is 1, these two steps are unnecessary. But can I get the answer this way? Yes, but could I go from the problem to the two factors? Yeah. So let's try some examples. X squared plus 2x minus 15. What's AC? Well, what's A? And what's C? Negative 15. So what's 1 times negative 15? Negative 15. What is B? Okay, maybe we need to label these. What's B? What two numbers multiply to be 15? 1 and 15, 3 and 5, right? Which combination of these two are going to give me a positive 2? Keeping in mind that when I multiply them, I have to get a negative 15.
Negative 3 and 5.
Negative 3 and positive 5? Negative 3 and positive 5? Because negative 3 times 5 is negative 15, and negative 3 plus 5 is positive 2. Got it? X squared minus 3x minus 10. What's AC? Negative 10. And what's B? Negative 3. What two numbers multiply to be 10? 1 and 10, 2 and 5. Which combination of these are going to give me, multiply together to give me negative 10 and add to be negative 3? Negative 5, positive 2. Okay, so far? What about this? X squared minus 10x plus 21. What's AC? 21. What's B? Negative 10. What two numbers multiply to be be 21 and add to be negative 10? What kind? Negative 7 and negative 3, right? X squared plus 14x plus 24. What's AC? 24. What's B? Okay, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Good. 2 and 12. Notice some things for me real quick. What's the sign of the last number in these two examples? Positive. What are the signs in the answers? The same. If I'm multiplying two numbers together and get a positive number, they either both have to be negative or they both have to be positive, right? Okay. What about the sign of the middle number? What does that tell you? Which one it is, right? What if the last number is negative? The signs are going to have to be opposite because when you multiply two numbers together and get a negative number, one of them has to be negative, doesn't it? What does the sign of the middle number tell you this time? Yeah, so earlier they said which one is bigger, right? Except negative 5 is not bigger than positive 2, but I understand what they meant, right? Which of, like if we looked at the absolute value of that number, which one would be bigger, right? Okay. The last thing is, I wrote this down for 15, I wrote this down for 10 to help you kind of get thinking. I didn't write it down for 21 because you got that one pretty quick, but then I did write it down for 24 because there was a lot of factors, right? So this is not required right here. This is just kind of help you figure out what numbers are multiples to help you figure out what B should be, what the two numbers are that add to B, right? So do you know all your multiple rules? Like, how do you tell if a number is divisible by 2? If it's even, right? If it ends in a number divisible by 2, you know that, right? How do you tell if a number is divisible by 3? Is 45 divisible by 3? It is. Do you know how I know that really quickly? And it's not just me. Other people know it too. I'm not just making this up. What is 4 plus 5? 9. If I add the digits together and I got 9, is 9 divisible by 3? Then that number is divisible by 3. Like 45 is. Okay? 2, 3, 7, 8. Is that number divisible by 3? Well, it's 2 plus 3. 5 plus 7? 12 plus 8? 20. Is 20 divisible by 3? Then neither is this number. Does that make sense? How do you tell if a number is divisible by 4? If it's 2, if it's divisible by 2, the last number is divisible by 2, right? If it's divisible by 4, the last 2 numbers are divisible by 4. And sometimes that helps and sometimes it doesn't, right? How do you tell if a number is divisible by 5? If it ends in 5 or 0, very good. How do you tell if a number is divisible by 6? If it's divisible by 2 and 3. 7, there's a trick, but it's not really a trick. It would take longer to do the trick than to put the number in the calculator and divide by 7. Okay? But for the record, to tell if a number is divisible by 7, first of all, do you know 45 is divisible by 7? It's not, right? 49 is divisible by 7, but not this. Well, let's just use 45. That's an easier, or 49. That's an easier one to show you. Take the ones digit, which is the 9, and double it. 18, right? Subtract the number that's left, and you get 14. Is 14 divisible by 7? Then that number is divisible by 7. 798. Is that number divisible by 7? Well, take the ones digit, that's 16. What's left is 79. Find the difference of those two numbers. What is that, 63? Is 63 divisible by 7? Then so is 798. You see what I'm saying? It's like a trick, but it's not really a trick because it takes some calculations to get done. Okay? 8 is also, there's a trick, but it's not a trick because 2 is if it's the last number is divisible by 2. 4 is if the last 2 numbers are divisible by 4. And 8 is if the last 3 numbers are divisible by 8. Well, if I'm trying to figure out if 45 is divisible by 8, that doesn't help me at all, right? That's really only big numbers it helps me with. But it's a thing, right? How do you tell if a number is divisible by 9? The same way, yeah, first of all, you can use your fingers if it's just a 2-digit number, right? Or if it's not, it's the same kind of trick as 3. We know 45 is divisible by 9 because that's 9 times 5, right? But 4 plus 5 is 9, and 9 is divisible by 9, and so so is the number. How do you tell if a number is divisible by 10? If it ends in 0, right? There's tricks for 11 and 12. I don't really understand the trick to 11, or maybe I just haven't paid attention enough to it. The trick for 12 is kind of cool. It's similar to the trick for 6. You know, 6, it has to be divisible by 2 and 3. 12 is it has to be divisible by 4 and 3. So, there you go. Okay? I just thought you might want to know those tricks when you're trying to figure out what the things that multiply by to get AC to add to be B. Does that make sense? Do you have any questions on factoring trinomials? You good? If you do have questions later, what should you do?